Hello everyone. In this lesson we're going to expand upon what we've been covering the last few days. In the last few days we've been looking at how to graph quadratics, and we've been doing it by factoring. Today we're going to look at a more broad tool, so we're going to expand upon that tool of factoring and find one that works more universally. So to jumpstart that discussion and kind of justify our new tool, I'd like you to try the following two warm-up questions, which is recall what we've done the last few days by graphing by factoring and what we did in the last chapter, and just try this one. If I wanted to graph the following quadratic by factoring to find the x-intercepts first and then split them in half to find the vertex's x-coordinate, give it a go. So pause the video now, try factoring this quadratic equation, and then find the zeros. Don't go graphing the whole thing. You can just do it in the side margin of the note packet or along the margin of a piece of paper. And then unpause it once you've had a chance to try and want to see what we're talking about here. Okay, what you would have tried at first is, because there's no number out front, we can just do regular old what multiplies to be the last term, adds to be the middle term type factoring, and what numbers multiply to be 15 and add up to be 5. And you might have struggled with this because the only numbers that multiply to be 15 and add up to be 5 are there are no numbers. 1 and 15 add up to be 16, and 3 and 5 add up to be 8. So there's an issue going on. If I have Desmos helping me with it, you will see the graph for this shown equation right here, graph. There are no x-intercepts. This graph does not cross the x-axis, which is going to cause us some issues, because if it doesn't cross the x-axis, how am I going to find x-intercepts? Because I need to find x-intercepts in order to get the vertex's x-coordinate, because the vertex's x-coordinate is always halfway in between. So this kind of sets the whole dominoes going down because I don't even have the first step. So we have an issue going on. Show the picture right here. What we're going to do actually is we're going to go back to do some old ones that we had done prior, and I'm going to point out a pattern to you that was going on all along, but would have been pretty difficult to pick out on your own. So I just hope you appreciate the tool that we've been using of factoring is no longer useful. It doesn't do ones like this. Factoring is only going to be appropriate if the equation itself is factorable. If it's not factorable, there are no x-intercepts, there are no roots, and I can't find halfway between them because there are none. So what we're going to do is we're going to go back and we're going to do one like this, and then we're going to do it with just variables in there, and we're going to get a formula. So if I wanted to find where the x-intercepts for this graph were, so I could get the vertex's x-coordinate, and then I think you would know how the rest of the story goes, I would first ask myself, well, when is y going to be 0? Because that's where the x-intercepts are going to be located. So I set y equal to 0, and now I try to factor. If there's only two terms, I can only do greatest common factor factoring. So I look and see what's the biggest number I can divide out of -2 and 5, and the only number I can divide out of those is 1, so technically nothing. Then I do the variables. What's the biggest variable amount that I can pull out of x squared and x? Well, that's just an x. The first one has 2, the second one has 1, so I can divide an x out, and what's left behind is -2x plus 5. So once I have it factored, it looks like that. Now once I have it factored, I can solve for the x-intercepts. When will this be 0? Well, obviously when x equals 0. When will this be 0? I have to solve. I need -2x plus 5 to equal 0. I subtract 5, and then I divide by a -2, and that's going to leave me at 2.5. So there's my two x-intercepts. If I were going to graph this graph, crosses at 0 because it has a negative leading coefficient. The a value is negative. I know it's going to open downward, so when I sketch in between these two, I know the graph is going to look something like that. The vertex's x-coordinate is going to be halfway in between. If you don't know, by just looking at this kind of simpler case, you'd have to solve by averaging the two. Add them together and divide by 2, and that leaves you at 1.25. So that's where the vertex's x-coordinate is going to be. That's how we did it with numbers. Let's check with Desmos just to make sure that we've done it right. When I check with Desmos, we've done it right. X-intercepts are at 0, 2.5. The vertex's x-coordinate is at 1.25. If you want the y-coordinate, you plug 1.25 in for x. You know how that goes, hopefully by now. We've practiced enough of them. What we're going to do is use this last one we did with just with numbers in there to guide us as a template when we have just variables. Because when I do it with just variables, I'm going to get a formula that works always. So what's the first thing we did? We said we want y equal to 0 because I want to find the x-intercepts. So 0 equals ax squared plus bx. A and b are technically numbers, I just don't know what they are. because I don't know what they are, I cannot assume that they have any number in common I could divide out. So they act a lot like this -2 and 5. There's no number I can divide out of them. So I check, but without knowing what a and b are, I can't assume that they have anything in common. So I move on to the variables. What's the most amount of variables that I could divide out? Just a single x. Just like in the last case. That's why it's a good template. What's left behind is an ax plus b. Now it's completely factored. I want to find the x-intercepts. So I have two items multiplying each other, making 0. The x-intercepts will occur when each factor is equal to 0. So this will be when x equals 0, just like in the last one. This one I need to solve. I need ax plus b to equal 0. Well, a and b are numbers, so what's the first thing that I did? I undid the add 5, so I need to undo the add b. Subtract b, I'll then get ax equals -b. A is a number, so I divide by a, and I get -b divided by a. And so long as I'm doing a greatest common factor factoring problem, it'll always be the x-intercepts will be at 0 and -b over a for a quadratic. But I want to know where the vertex's x-coordinate is. So how do I find that? I average these two. I'm going to add them together and divide by 2. When I add them together, I get -b over a, and then divide by 2. This looks a little confusing to look at because it's like a fraction over a fraction. So instead I'm going to write it as -b over a. And this is the same as this bar, this fraction bar is the same as just writing a division. Divide by 2. Well, recall, this is a fraction division question. If I have division with fractions, I can always make it be a multiplication question. And dividing by 2 is the same as multiplying by a half. I multiply by the reciprocal. And then how do I multiply fractions? I multiply straight across. So it turns out that the vertex's x-coordinate, when I multiply straight across, it will always be located at -b divided by 2a. And that's an incredible finding. That's a big time shortcut. The x-coordinate for the vertex will always be located at -b over 2a. It turns out that this formula works whether the original equation was factorable. So it would have worked for all the ones we did before. I couldn't have shown it to you earlier than right now because you needed to know how factoring worked to even get there. But this is the most helpful because it works on ones where factoring would not be appropriate, where ones that are not factorable. So this works always and forever. It's like a universal sword. Summarizing everything we know about graphing quadratics now, there's a lot of old things we know, and now we know a new thing. We knew from before that if a, the leading coefficient, is positive, the graph is going to open up. That's old knowledge. If a is negative, the leading coefficient is negative, the graph is going to open down. That is also old knowledge. Here's the new one. That vertex's x-coordinate always falls along the axis of symmetry, and we found that that is always going to be at -b over 2a. The axis of symmetry will always be at -b over 2a, which means the vertex's x-coordinate will always be at -b over 2a. Once I know the x-coordinate, how do I get the y-coordinate? I plug that x value into the equation to get the y-coordinate for the vertex. And also, like always, the y-intercept for the graph will always be at 0, c. If I put 0 in for x, this will disappear, this will disappear. The only term will be left will be the constant c term, and I'm done. Just to show you that this -b over 2a for the vertex works whether it's factorable or not factorable, I'm going to show you a little picture I put together using Angry Birds. So if you've ever played Angry Birds, it turns out Angry Birds uses the equations of quadratics, x squared plus bx plus c. Here's the path of a launch of one of the birds. And then here is a matching parabola where I've altered how high or how low it is. And what I want to show you is even if I go to a quadratic that has no x-intercept, so I'm going to drop this thing way down here below the x-axis right there, even if it has no x-intercepts, it will still fall along the axis of symmetry at -b over 2a. So even if it is not factorable, the vertex's x-coordinate will always be located at -b over 2a. And that is very, very, very helpful. Let's try one. I want to graph the following, y equals x squared plus 2x plus 5. Before today, we would have had to do it by factoring. We would have said, okay, what numbers multiply to be 5 and add up to be 2 so I can find the x-intercepts. The problem is there are none. No numbers multiply to be 5 and add up to be 2. So we have to use our new tool of the vertex's x-coordinate is at -b over 2a, which is going to be where the axis of symmetry is going to fall. So it's going to be at -b over 2a. might be wise if we start off just by writing what a, b, and c are. A is the number in front of x squared, so in this case a 1. B is the number in front of x, so in this case a 2. C is the number constant term all by itself, in this case a 5. It turns out A and B are going to be used to find the vertex. C is going to be used to find the y-intercept. They all serve a different role. The axis of symmetry is going to be along the line negative b over 2a, which in this case will be along negative 2 over 2 times 1. That will just simplify to be negative 1. So my axis of symmetry is going to be along x equals negative 1. That's going to be where the vertex's x-coordinate is. The vertex's x-coordinate is going to be when x is negative 1, because it has to be along the line of symmetry, which we proved was going to be at negative b over 2a. Once I have an x-coordinate, how do I get a y-coordinate? I put it into x in the equation. So I put negative 1 in for x in the equation. Wherever I see an x, I'm going to put a negative 1 because that's the x-coordinate of the vertex. That'll make 1 minus 2 plus 5, which equals negative 4. So my vertex will be at, that'll be a positive 4. I don't know why I said negative. The vertex's coordinates will be at negative 1, 4. Right there. The last one is the y-intercept. The y-intercept is always going to be when x is 0. If I put 0 in my equation, I'm going to get 0 plus 5. So my y-intercept is at 5. I can sketch the right side of this graph now, and the left side is just a mirror image. And then I'd be done. That is the process of using negative b over 2a to graph a quadratic, because factoring wouldn't work because this graph is not the equation is not factorable because the graph has no x-intercepts. The next example is not in the note packet because it doesn't take that long. I just wanted to show you just a few special cases. If they give you ones where it's not clear what a, b, and c are because it's not all the way laid out, be aware it's probably because one of them is 0. So if I have y equals negative x squared plus 2x, it doesn't look like there's a c, but there really is. It's plus 0. Now it's clear that a is negative 1, b is 2, and c is 0, and you can go along finding the vertex and the y-intercept. Over here again, it's y equals x squared. It doesn't look like there's any x's. It's because it's 0x minus 7. Now a is a 1, b is a 0, and c is a negative 7. So just be aware if they give you one of those special case ones, it's probably because one of the a, b's, or c's are 0. I would like you to try one like the first one that we did. So use the fact that the vertex's x-coordinate is at negative b over 2a to find the vertex, and then find the y-intercept and sketch the graph. So use the first example that we did as a guide. Pause the video now, unpause it once everyone's had a chance to try, and you want to see what the answer is. So pause the video now, please. Okay, if I go through it, here's what it looks like. The axis of symmetry is at negative b over 2a. A is 2, b is 4, c is 3. Negative b over 2a will be negative 1. That's also going to be the vertex's x-coordinate. If I know the x-coordinate for the vertex, how do I get the y-coordinate? I put negative 1 in for x in my equation. When I simplify it out, order of operations, I get 1. So my vertex is at negative 1, 1. The y-intercept is when x is 3. If I put 0 in for x, 0, 0, 3. It's this green point right here. I sketch in the right half, and I reflect over it and get the left half, and I've got all the points I get from this process. When you do this process, you're always going to get 3 points. You get the vertex, you get the y-intercept, and you get the y-intercept's reflection. The very last part of this lesson deals with some vocabulary. It turns out when you're graphing quadratics and they make these parabola U-shapes, you're always going to end up with either a maximum or a minimum. It's going to be a minimum if your graph opens up, and it's going to be a maximum if your graph opens downward. So the minimum is going to be the lowest point when the graph opens upward, and the maximum is going to be the highest point when the graph opens downward. Be aware the maximum and minimum always have to occur at that vertex, but now we have a shortcut for finding where the vertex for any parabola is located. The x-coordinate is at negative b over 2a. You might ask yourself, if a graph opens upward, how do I know it opens upward? Because you look at the leading coefficient. If the a value out front is positive, you know the graph is going to open upward. We have to have a minimum. If the graph opens upward, it will never have a maximum because the graph keeps opening up and up and up. Likewise, if the leading coefficient a is negative out front, you know the graph is going to open downward. If it opens downward, there has to be a highest point, and that's going to occur at the vertex, which is going to be the maximum. If the graph opens downward, be aware a downward opening graph will never have a minimum because it keeps going downward, downward, down. Let's try an example. If they gave us the following equation and asked us, does the graph have a minimum or a maximum, and then what is it? The first thing we'd have to do is identify the fact that I can see the leading coefficient is a -3. That tells me the graph is going to open downward, and that means there has to be a maximum. So you would say, since the graph opens down, there will be a maximum, but no minimum, because it'll just keep going down. How do I find the maximum? Well, if it's opening down, the maximum is going to be at the vertex. And I can find the vertex by doing negative b over 2a. So first thing I would do is identify what a, b, and c are. A is -3, b is -12. Here, let's do it one step at a time. C is 10. Once I've identified a, b, and c, I can find the vertex's x-coordinate by using -b divided by 2a. Negative of a -12 makes a +12, divided by 2 times a is -3 makes -6. Positive divided by negative makes a negative. If I have the vertex's x-coordinate, how do I get the y-coordinate? I substitute -2 in for x in the original equation. Then I just do order of operations, and I get an output of 22. So I know that the vertex is located at -2, 22, which means the maximum for this graph is going to occur at -2, 22. Applications for this are really endless, but example would be like that Angry Bird one. Now I have a formula and a quick process that I could program a computer to tell me how high that would go. Or if I was launching rockets or any type of scientific field that studies the movement of anything through the air in a gravitational field, I have a process for finding how high that object goes. So this one goes 22 high at an x-coordinate of -2. That's it for today. Thank you very much and have a good one.